In this video, we're going to discuss radicals. We're going to simplify, we'll add, subtract, multiply, we'll solve radical problems. So my first problem here is to simplify. So I'm going to simplify the square root of 12. What that means is I'm going to break apart 12 into perfect squares. So 12 is 4 times 3. 4 is a perfect square, so I can reduce or simplify square root of 12 to be 2 times the radical 3. So I always want to take out the perfect squares and leave what little I have to leave behind. So simplifying 8x to the 6. So we're going to break apart 8 to 4 times 2. 4 is a perfect square. And x to the 6 actually is a perfect square. That's x to the third times x to the third. So when I take out my perfect squares, I get 2x to the third, and what's left is the radical 2, or the square root of 2. When I simplify a fraction here, I have to be careful because I can never have a radical number in the denominator. So in order to do that, I'm going to rationalize the denominator. So I'm going to multiply by the square root of 2, because the square root of 2 times the square root of 2 gives me just the number 2, so that would be my new denominator. So that works because I'm allowed to multiply anything by the top and the bottom being exactly the same. So my numerator becomes 3 radical 2, and square root of 2 times square root of 2 is square root of 4, which is 2, and that simplifies without a radical sign in the denominator. Now in this case, I have 2 minus the radical 5. So now I have a binomial here, so I'm going to put parentheses around that, and I'm going to multiply by the conjugate, which means the same terms, okay, it's just the different sign. And when I do that, if I do that, what happens is my middle term drops out, and what I have is 2 times 2, which is 4, and square root of 5 times square root of 5 is negative 5 here because I'm subtracting 1. So now I have 4 minus 5 in my denominator. Now in order to let me do that, I have to multiply this by 1, so it has to be the exact same thing on the numerator and the denominator. So now I'm going to multiply square root of 5 times 2 plus the square root of 5, and I get 2 radical 5, and radical 5 times radical 5 is plain old 5, and that's over 4 minus 5. So let's reduce that. 4 minus 5 is negative 1. So I have negative 1 times 2 radical 5 plus 5, and I can just rewrite that negative 2 radical 5 minus 5. Okay? So in both cases, I do not want to have any radical sign in the denominator. In this case, this is kind of more simple. I just multiply by the square root of 2. Here I multiply by the conjugate, which will get that radical sign out of the denominator. Now we're also going to continue doing more work, and we're going to add radicals. Now the thing about radicals is that they have to be the exact same number within the radical sign for us to put them together. So 2 radical 2 plus 3 radical 2, they're both radical 2, so I can just add them. I have 2 of them here, 3 of them here, so that is 5 radical 2. In this case, I have 3 radical 5 plus 2 radical 3. I have 2 different radicals there. So I can't put them together. They're going to stay separate, and that will be my answer. So I don't need to do anything with that one. Now when we multiply, we are going to multiply just using the distributive property and multiply radicals. So square root of 6 times square root of 2 is the square root of 12. We will simplify that. Square root of 6 times square root of 3 is square root of 18. Now I have to go back to what we just said, simplifying. This is 4 times 3. This is 9 times 2. So the square root of 4 is 2 radical 3. And the square root of 9 is 3, and the leftover is radical 2. So that is how we simplify after we multiply that. And then what we're also going to do is we're going to solve. So we're going to do the same inverse operations, except now we have a square root sign. So let's get rid of the 3 first. We're going to subtract that on both sides, and I get the square root of x is equal to 2. And what I'm allowed to do here is, in order to get x by itself, I'm going to have to square this. The square of a square root just gives me the variable x. But if I square this side, I need to square that side. 2 times 2 is 4. And then I solve my radical sign. Now, if I want to check that, I can plug that in up here. Square root of 4 is 2. 2 plus 3 is 5. That does indeed work. Okay? And what we're going to do here is talk about graphing radicals. And a radical function is, when you graph it, looks like half of a parabola. So what we're going to do is it's going to have some starting point and then kind of look just like a little bit of a curve, but half of a parabola. So in this case, here's my half of my parabola. And same thing that I've had before, this is my y-intercept. So in this case, I start, my beginning point of my radical graph begins right there. And from that point, I'm just going to make my half a parabola. Okay, so it's that easy to graph. Now, one of the things we have to pay attention to is that the domain of a radical function means that what would be the x values. So we can never have a square root of a negative number. We're not allowed to have that. So what we want to do is make sure everything that's under the radical sign is a positive number. So I take my number that's inside my radical sign, and that has to be equal to 0 or greater than 0. So we're going to say that has to be greater than or equal to 0. And I'm going to add 3 in this case to both sides. So x has to be greater than or equal to 3. That means any number I pick for x greater than or equal to 3 will make this a positive number under the radical sign. So this is what we call our domain. Okay, so let's do some practice problems with that.